need to just grab the book.
All right, we're going to do a couple parabola problems with the geometric application. The geometric application is all about finding the focal point. And there'll be a video that I'll post that'll explain why that's super important. But that's really, when we talk about geometry of parabolas, we're really concerned with what that focus point is. So if I look at 4f equals 8, obviously that focal point then is 2. And so what that means is this guy has a vertex of 0, 0. So here's 0, 0 for the vertex. And the focal point then is 2 spaces away from it. So 2 spaces, it's oriented vertically because we've got x squared, it's a regular parabola like we're used to. The directrix then is 2 spaces below it. This is your directrix. And that is at y equals -2. And because that focal point is 2 spaces away, we should expect to see something relatively fat. And so the way I have you guys think about it is, let's put this into the form that we learned about it in the previous units, in Unit 3. So if we divide that 8 off, this is 1/8 x squared equals y. And so when it's 1/8 x squared, we know that that is a compression, and it's going to squish that parabola vertically, and it's going to make it look fat. If we wanted to find an actual point, plugging in for the equation for 4 and solving for the y value is going to be relatively easy. And you can kind of learn that just by, number sense. So I know that 4 squared is 16, which is a multiple of 8. So that's going to give me y equals 2. So the point 42 for 2 and -42 for symmetry reasons. So this is our parabola, and it does indeed open up wide. So the next one we won't graph all the way, but we will look at the math and talk about what we see. So this one is a y squared, and so what that means is it's opening horizontally. It's centered on the y-axis. It's moving up and down the y-axis. This has a vertex of 0, 0. So just like the other one. But what we do need to think about is, what is that focus? How far away is the focus from the vertex? Well, this has a focus of -7. 4 times -7 is -28. And so what does that mean? That means your focal point is -7 units away from the vertex. So -7 units, 1, 2, 3, 4, 5, 6, 7. That puts me all the way here. That means our directrix is 7 units backward. So here's our directrix. And so with that focus being 7 units away, like look how fat our previous one was by being 2 units away. 7 units away is going to make it really fat. It's going to be like this. And so again, we're just sketching and thinking about how all these numbers fit together. We don't actually make graphs where we find actual points most of the time. All right, writing equations of parabolas. This is a lot easier when we think about the geometric definition than it was when we were doing it just purely algebraically. So keep in mind that f right here, that is the distance the focus is from the vertex. So when they give me that the origin is at 0, 0, and the focus here is at -2, 2, 3. So here's the origin. 2/3, 0 is here. That's our focus. This is going to be our parabola. And so we need to figure out which equation is that. That one opens up sideways. And so since it opens up sideways, it is going to be the y-squared equation. And so all we need to do to write the equation is the focus is 2/3. We're going to plug it in. Y-squared equals 4, 2/3 for the focus. So our equation is y-squared equals 8/3 x. All right, so the next one, it says vertical axis. That means it is oriented vertically like this. So automatically would use the y-squared equals 4f x. It tells us that it's at the origin, 0, 0. And then we have a point. This would be our x and y. So the first thing we do is plug that in to solve for f, so we have our equation. Again, f is kind of like related to a. So this is another way to solve for that a value like we were doing in Unit 3. So I have 12 squared equals 4f times negative 2. So I have 144 equals negative 8f. F looks like it is negative 70. Is that right? What's F? Negative 18. F is negative 18. I was one step ahead. Okay, so since F is negative 18, I can now take that back right here into our equation, and I can then say y squared equals 4 times negative 18. I think that's the negative 72. So that is our equation. It's a lot easier than how we were doing it back in Unit 3. Sometimes they give us the graph of parabola in this form. This looks like vertex form. What we need to do is transform it to be our geometry definition so that we can answer all these questions about the focus, the directrix, all of that stuff. So our form for geometry is this one's a y squared right here. So I have y squared equals 4fx. And so the only difference is this one is not centered at 0, 0. So we have this x and y plus or minus going on. So when I look at this problem, I see this plus 2. The first thing I'm going to do is move him over. So I have x minus 2 equals negative 1/8 y plus 3 squared. And when I look at this, the next thing I need to do is I need to move this negative 1/8 over. So now it's going to be negative 8 x minus 2 y plus 3 squared. So this negative 8 right here, that is 4f. So 4f equals negative 8. So that means f is negative 2. This has a vertex at 2, comma, negative 3. This opens to the left because your focus is negative. So if I sketch that, you should get something that looks like this. All right, so the focus being negative 2 spaces away, that does make us have a fatter looking parabola. It is not skinny. So plug in a point. I found a nice point on there, and we get a graph that looks like this. So sometimes they give us just 2 pieces of information. They give us a vertex and the focus. And so at first you might not be sure how to put this information together. One strategy that I always use is to just graph those 2 points. That's going to let you know which equation you're using. You have the x squared or y squared. It's going to tell you the direction that it opens. It's going to tell you all that information. It'll even tell you what the focus is just by giving those 2 points. So I go ahead and graph them. Negative 1, 2 is right here. That is our vertex. And it tells us our focus is at 2, 2. And it's really easy to get mixed up. But what I do know is that the space between the vertex and the focus is 3. So that's my F. And I happen to know that all these conic sections, they open up around your focal point, right? So it's going to open like that. Well, parabolas that open sideways like that are y squared parabolas. So y squared equals 4fx. All right, so we're going to plug in the stuff we know. I know that the y value of my vertex is 2. So it's y minus 2 squared. I have equals 4. I know that my f is 3. And then I also know the x value of my vertex is minus 1. So x can be minus negative 1, so it's plus 1. This is the equation of my parabola. Y minus 2 squared equals 12 x plus 1. Way easier than all of the stuff that we were doing in the first unit with parabolas. All right, the last example we did is one where you have to do complete the square. So they're giving this to us in general form. And so we're to complete the square the same way we've always completed the square. So I have x equals, I need to group these two things together and divide that negative 2 out. So I have negative 2 y squared. Now it's going to be minus 2y. I'm going to leave a blank and a minus 3. When I complete the square, I'm going to cut that number in half. So it's going to be negative 2 y minus, half of 2 is 1, so y minus 1 squared. The problem is, when I FOIL that out, I'm going to have an extra 1 squared right here. So 1 squared is 1. And that plus 1 really means minus 2. So I have to put a plus 2 on the end there, which means negative 3 plus 2 is a minus 1. Okay, now if I want to then continue transforming this into our geometric form that we've been studying, I'm going to move the 1 over. So I have x plus 1 equals negative 2 y minus 1 squared. And then I'm going to divide the 1/2 off. Negative 1/2, I guess, or the 2, divide that off. X plus 1 equals y minus 1 squared. So from this form, I can answer all of that stuff. I know that this is a sideways one because I have the y squares, and I know it opens left because the focus is negative. If I solve for that focus for f equals negative 1/2, I get f is negative 1/8, which means this guy's going to be skinny. I know that it has a vertex at negative 1, 1. So yeah, we get all the information we need, but you will need to complete the square sometimes to transform which version of the equation it's in.